Good afternoon, participants at various remote centers and in the studio. So as per the timetable, in this section, we will discuss Introduction to Matlab. The name of the course is Optimization using Matlab. And also, as you saw in today's morning session or in yesterday's session, that optimization problems require putting data in matrix form and then manipulating the matrices. Matlab provides very easy interface to create, manipulate, edit matrices. So accordingly, it is widely used in the scientific and engineering community for problem solving. The name Matlab itself comes from matrix laboratory. So today, what we will see is a very you can say layout of the contents as I will cover. So we will see the graphical user interface layout of Matlab, how to create matrices, how to manipulate them, and then how to solve simultaneous linear equations, and a very brief introduction to programming. Tomorrow we will see some functions of optimization toolbox of Matlab, and also some more programming which may be useful in optimization. So I'll switch to the Matlab environment. So the Matlab which I'll be using is 2014 release. Now we have 2017 release with us, but that hardly makes any difference for what we are using. Let me increase the size of the font first. Okay. So what you see on the screen is the GUI of Matlab. Like all softwares, it has a title bar, a ribbon for various options. And then this is the main area in which we have the command window, a workspace window, and a current folder window. In the command window, we have the command prompt at which we issue the commands. And whatever commands we issue, that will result in creating some variables. So those variables will appear in the workspace window. And of course, the current folder shows the listing of the directories and files which are in the current folder. And the current folder itself is shown here. Right? As you can see here in documents, the Matlab directory. So when you install Matlab, it creates a directory with the name Matlab under My Documents, where it will store by default whatever files you create. Now, we have a number of centers with us and a number of participants in the studio. So a large and a heterogeneous group. So many of you may be very well versed with Matlab. Many of you may not be even aware of this. So I will just go step by step. And those who are well versed with it, please excuse, because we have to keep in mind the whole group. Now, we know how we create variables, whether on a copy or in a computer. If we say a is equal to 4, right, that creates a variable a, and a value of 4 is assigned to it. So the command is executed after we press enter. So when we press enter, you can see the command which was issued is again repeated here, and in the workspace window the variable a appears with its value. Let me decrease the font size a little bit because that will occupy the command window in one go only. Okay. So we issued a command here, a is equal to 4, and the variable that is created, it appears in the workspace along with the name and the value. Right? Now let us issue another command, say b is equal to 5. So obviously we are creating a variable b and assigning it a value 5. But this time we put a semicolon at the end and then press enter. So the effect is same. The only difference is that the command is not repeated if we put a semicolon at the end. Otherwise, the net result is same. The variable is created and a value is assigned to it. Now the two variables that we have just created, they are scalars. But we require to work with matrices. They may be two-dimensional matrices or vectors matrices or column matrices. So if we are using some other programming language, say C, it is you have to write a code for creating matrices. But in Matlab, matrix is a basic data type. So we can very easily create a matrix. For example, we say C is equal to, in square brackets, I just write some values, say 1 space 3 space 5 space 7, and then we close the square bracket. So we have created a now row vector. I am not putting the semicolon at the end so that you can see the output of the command. So what you see here is C is equal to 1357. In the workspace window also, you can see the variable name and its value in square brackets. And here you see the values being separated by commas. So we create some. Again, the effect is same. So when you are issuing the command, you may separate the values with a space or you may separate the values with a comma. It's one and the same thing. The effect is same. A vector is created. I'm going to clear the command window, and to clear the command window, the command is clc. Now let us create another matrix. Say 1 space 3 space 5. I'm just taking arbitrary values. Then before we close the square bracket, I put a semicolon and then say something else. Say 4, 6, 8, and then put the square bracket. Now I have entered 6 values. The first 3 are separated by a space, and then we have a semicolon, then more 3 values. So when you press enter, now you will see we have created a matrix, a 2 by 3 matrix. So if we put a semicolon, that marks the beginning of a new line within the matrix. So if we put a semicolon at the end of the command, that means we don't want the command to be repeated on the screen. But if we put a semicolon within the brackets, that means a new line in the matrix. So similarly, say if we say G, some value, say 1, 2, 3, 4, semicolon 5, 6, 7, 8, semicolon 9, 10, 11, 12. So we expect to get a 3 by 4 matrix. So this is the first row. Then after semicolon, the second row. Again after semicolon, the third row. Okay. So far we have seen how to create a vector, a row vector, and how to create a two-dimensional matrix. Now let us issue another command. Say 1, semicolon 2, semicolon 3, semicolon 4, semicolon 5, like this. So we know that a semicolon means beginning of a new line. So what this will do is create a column vector. Now each row has only one value. So this is obviously a 5 by 1 matrix. I'm again issuing a CLC command to clear the command window. Now let us see another method, how to create matrices by some more means. Say we have A is equal to, say, 1 colon 6. So what does this mean? We may even put a square bracket, or we may not put it here. So it is now a colon, not a semicolon, but a colon, 1 colon 6. So what this does is it creates a row vector beginning with 1 and ending with 6 and with a increment of 1. So 1, 2, 3, 4, 5, 6. Now we are saying 1 colon 2 colon 6. So let us see what this will do. It creates a matrix vector 1, 3, and 5. So what happens when we give only two values separated by a colon? Matlab will create a row vector with this being the first value and this being the last value. Whereas if we give a third value in between the two, that is taken as the delta or the increment. So starting with the first value, it will add 2 to this, produce the next value, add 2 to this, produce the next value. Now if it adds 2 to 5, it becomes 7, which is beyond 6. So it terminates at 5. So we can give a increment like this. So we may start from any value and go up to any value. So if we say -2 to 3, that means a default increment of 1, starting with -2 and going to 3. But if we say, now we'll have starting with -2 and adding 1.5 to it and getting the vector. So that increment may be an integer, it may be a floating number. Now we are creating matrices for demonstration, right? So we have a matrix with us, which is an F is there, G is there. It's a big one, so it's not showing it here. But if we increase its size, that will also be shown. So F, G is there. Okay. So we have a matrix G which we created just now, which is a 3 by 4. So the first thing is to create matrices. That is fine. Next is how to edit them. For example, we may have to edit them due to some mistake or during programming we have to write program where we are assigning new values to certain elements of the matrix. So let us see what will this command give us. G, then a bracket, then 2 comma 3. When we give this command and just press enter, it says answer is 7. So if you look at this matrix G, the value 7 lies in the second row and the third column. So basically here we specified the indices of the row and the column separated by a comma. So we just extracted the value which is at second row and third column. So that means if I want to extract, say, this value of 10, then I need to give G3 to third row and second column. That will give us 10. So we are giving a command S is equal to G3 comma 3. We are familiar with this. It will give us a value at third row and third column. But this time we are assigning that value to the variable S. Earlier we just issued the command without specifying any variable. So by default Matlab was creating a variable ANS for answer, which is a default variable that Matlab creates if we don't specify a variable to which the result is to be stored. Okay. Now I'll use the ANS variable only now. So what will this do? So as you know now that when we give the name of a matrix and then within brackets give two values separated by a comma, before comma we have the rows, after comma we have the columns or column number, right? So here we are saying that first and third row and second column. Right? So first row, second column, third row, second column. So that means 2 and 10, these two values will be extracted. So you can have a look at the command and the output and the matrix. Okay. So when we have to specify multiple rows or multiple columns, we specify them as vectors. That is the main fundamental of Matlab, that any multiple values you want to specify, you specify them as vectors. So we have a G matrix. So similarly, if we say first and third row, comma, now we also want to specify more columns. So we say first and fourth column, right? So it will look in the first and third rows, and within those two rows, first and fourth column. So we'll get the values of 1, 9, 4, and 12. Again, you can have a look at the matrix, the command, and the output. Now we are saying first and third row, and then column numbers 2, 3, and 4. Because remember, when we put a colon, it starts with the first value and goes up to the last value. So these two values are separated by a space. You can also put a comma if you like. So first and third column row, and then second, third, and fourth column. Okay. So the same technique we can also use to replace some values. For example, we have the G matrix as this. So if I say G second row third column is equal to say 55. So now we are assigning a value of 55 to the element at second row and third column of G. So that means 7 will be replaced with 55. Right. So this is the matrix, original matrix G. Now we have changed the element at second row and third column with a new value, and this is the new matrix G. So using same logic, we can also replace multiple values in one go. Say first and third row, and then second and fourth column. So because this will result in 4 values, so we have to, let me do this. First and third row and second column. We know this means 2 and 10. So we need to give 2 values, and these 2 values should also be as a column vector, because we are replacing it basically the values which are in a column 2 and 10. So these 2 new values should also be specified as a column. So 2 has been replaced with 11 and 10 with 111. We have learned how to create row vectors, matrices, column vectors, how to extract single and multiple values, and how to replace single and multiple values. You will be comfortable when you start doing this yourself. Now let's do another thing. Say I want to extract the complete third column, right? That means first row, second row, third row, and then the third column. That is how these three values will be specified. So normally you may say I can write like this: first row, second row, third row, and then third column. This will give us 355 and 11, but this is not the right way to do. I'm coming to that. So we get 355 and 11. Similarly, we may do the same thing in a shorter way by saying 1, 2, 3 rows, that is 1, 2, and 3, comma, third column. So this will also give me the same thing. But remember, we want to extract all the rows because this complete column it spans on all the rows. So the shortest way is to say, so if you put only a semicolon, that means all. So here we are saying all rows and third column. So then these three values will be taken out. Similarly, what this command will do is we are saying second row and all the columns. That means the complete second row, because this specifies the row number and this specifies the column number. So it's row, second, and all the columns. Now, this technique of specifying all the rows or all the columns, it can be very conveniently used to say delete an entire row or an entire column, or more than one row and more than one column. For example, we learned that if we specify some index, say all rows, third column, and then we specify some values, this will replace 3 with 88, 55 with 99, and 11 with 33. So if we issue the same command, but this time we just specify a empty or null matrix. So what we are saying is that replace all the rows and the third column, just delete it. Right? That means the third column is to be deleted. So what you see here is that the matrix G, which was earlier 3 by 4 matrix, now it is a 3 by 3 matrix, with the third column gone. Similarly, I may delete the first row. Now we are deleting the first row. So now it is reduced to a 2 by 3. So that is how we can create and edit the matrices. So if there is any query, we can stop and ask at this time.
So there is 4 into 4 matrix, and we have to make it 2 into 2 matrix. That's simultaneously what we have to create now.
So the question from an audience in the studio is that there is a 4 by 4 matrix and we want to convert it to 2 by 2 matrix. What can we do? What single command can we issue to do that? It depends on out of those 4 by 4 values, which values do you want?
Suppose that third column.
Yeah,
column.
That's what I'm saying, right? So, yeah, I agree. Okay, I'll just create a matrix. So this is just a Matlab command to create a matrix, just for you can say teaching or whatever. Right. The command name is magic because it creates a matrix in which the sum of elements in the rows, in the columns is, and in the diagonal is same. So we have a 4 by 4 matrix. Now what is your question?
You have to make it 2 by 2.
No, but which values? You see.
Eliminate third row, third column and fourth column, and third row and fourth row.
So you want 16, 2, 5 and 11? Yes. Okay. So his question is that there is a matrix, a 4 by 4 matrix like this, and we want a matrix, we want to extract a 2 by 2 matrix which is 16, 2, 5 and 11. Right. Okay. So what we have is, we are talking about the first 2 rows and first 2 columns. Right. So you may say first 2 rows and first 2 columns. So we are not deleting the other rows and columns, we are only extracting them, right? So the Z will remain as such. So I'm creating a new matrix Y which is equal to 16, 2, 5 and 11. So this is the Z matrix and this is the command, and we are creating a new matrix Y which is this. So that's what I said, that as you practice then you will have a grasp of it. But, pardon? And now we have a new matrix Y which has 60, which is a 16, 2, 5 and 11, which is these 4 values.
Excuse me, sir.
Yeah.
Can we use that answer variable in our assignment commands?
Well, in any programming language, it is not advisable to use keywords or reserved words in your own programs or as your own variables. Okay. So we have a matrix Y which is 2 by 2, and let us say we have a matrix. We create a matrix X which is 3 by 2. So a 2 by 2 matrix Y and a 3 by 2 matrix X. So we can straight away issue a command to multiply these two matrices X into Y. And we will have the new matrix because X was 3 by 2 and Y was 2 by 2. So the resulting matrix will be 3 by 2. So in a very simple fashion, we can just use the multiplication symbol for multiplying the matrices as well. But in other conventional languages, you have to write a program to multiply matrices. So of course, the rules of matrix multiplication apply. That is, their inner dimensions must match, so on and so forth. So the common algebraic functions to manipulate matrices, they are available in Matlab. But Matlab has a very good help. So you can always, whatever you wish to do, you can always explore the help and see what function will do that. Like for example, if we say want to just search anything, say matrix creates a matrix for a vector. So all the commands will come if you want to say see how to find a determinant. So you can type the full word determinant or you can type det. So it tells you, okay, this is a command to let me, okay, its font is smaller. Okay, so it doesn't let change the font of help. Okay, so like I have just I just wanted to take a determinant, so I searched the documentation for determinant. It says that is the command, and this is the syntax. D is equal to det of x, where x is the matrix, and it also gives us an example that this A, it produces a matrix and it happens to be a singular matrix, so that A produces a very small number. Okay. So it will be a singular matrix, a zero det, and changing A with this turns A into a non-singular matrix. Now that A produces 27. So you can very easily create a issue a command, find a command, because whatever you wish to do, you have to type that relevant word and the command will appear along with the suitable examples. Okay. So before we go further, because we have just by the way, although not directly applicable to optimization, but a very simple function uh, which can be useful. Say if we have a quadratic, right? For example, having a simple quadratic as x square plus 3x plus 2 is equal to 0. And we want to find the roots. So obviously we know the roots are -1 and -2 for this. But otherwise, what is the procedure? So our quadratic is x square plus 3x plus 2. So that means the coefficients are 1, 3 and 2. The coefficient of x square is 1. The coefficient of x is 3. And the coefficient of x raised to the power 0 is 2, or the constant is 2. So I may create a vector, say 1, 3, 2. So this vector now represents our quadratic x square plus 3x plus 2. So we just say roots of C. That what are the roots of this? So it says -2 and -1. So it was a second degree polynomial. So same way you can find the roots of any degree polynomial, 4th degree, 5th degree, anything.
So can it is possible for complex number also?
Yeah. So his question is that does it give you answer in complex number? So one quality of Matlab is it directly handles matrices. Second quality is directly handles complex numbers. For example, if we have a quadratic x square plus x plus 1, right? So it will have complex roots. So we say b is equal to 1, 1, 1. So x square plus x plus 1 is equal to 0. So we say roots d, it says minus 0.5 plus 0.866 iota and minus 0.5 minus 0.866 iota. So you can input complex numbers with this ease also, and it will also give you results in terms of complex numbers. So if you have a this can represent a 4th degree polynomial like 2x 4, 2x raised to the power 4 minus 3x cube plus x square plus 6x plus 7 is equal to 0. So just say roots of f and you get the roots. So it is that easy. Yeah. Just one example more on this. What we are saying here is an equation x cube plus 6x plus 3 is equal to 0. Because if any term of x is missing, that is that the coefficient is 0, we have to specify it as 0. Because when you give a roots command, the vector that it takes the rightmost value as for x raised to the power 0 or the constant. And the next value it will take as that of x raised to the power 1, then next x raised to the power 2, so on. So if any term is missing, you put a 0 coefficient for that. I'll need to use board. याद है. So I will now use the board to illustrate, because in our this so we have come to because matrix manipulation, there is so many functions, so whatever you wish to manipulate you can just find in the help, right? The main thing is how to create matrices or how to edit matrices. The next we come to simultaneous linear equations. So I'll just go to the board. So we have, say, x plus 2y is equal to 1. So now how do we solve it using Matlab? So we take matrices, we put it into the form A into x is equal to b. That is, we write the coefficients So all we need to do is create these two matrices, A and B. And after that, is the red color visible?
Yes.
And then we have to give a command like this. A backslash B. So it will give us the solution to x and y. And that's it. So here in the example I took 1, 2, 2, 3. So I just create a matrix. Oh, that creates a matrix A, and then we have B 1, 2. Right? So we say so we have the matrix A and the matrix B. Now all we need to say is A backslash B, and we'll get the result for x and y. So if you have whether simultaneous equations involving 3 variables, 4 variables, just create the two matrices and issue the command A backslash B. We can try some other way the value is not 0. I just create a 2 by 2 matrix 1, 3, 4, 2. Then say C backslash B. So B I am using the same one which I just created. So now the values of x and y are 0.4 and 0.2, where these are the coefficients, and B is same 1 and 2. So whatever be the size of simultaneous linear equations, you can just very easily solve it. So we can, yeah, one thing more, when we create matrices, say we just discussed that you create a matrix, a two-dimensional matrix like this,
that operation called that is the BT command C over BT. What was that operation?
Well, it is basically when you solve this, what you do is you take the inverse, and then you, and if you do it manually, that whole process is programmed into a single command backslash. So you just write A backslash B. That's it. Basically, it's a program which runs in the background in the command. So we just discussed that you create a two-dimensional matrix like this, that 1, 2, 3, then semicolon indicates a new line, and so you have a 2 by 3 matrix. You can also do it like this. To create a new line, you just press enter. Do nothing. The command continues. Only when you put the matching closing bracket, then only MATLAB understands that the command is now complete. Okay. So you may put a semicolon, you may just press an enter. It is one and the same thing. So we have, okay, we can just take one more example. PQ, and then say P backslash Q. So slash is for division. This backslash is to solve the equations. It also has a particular name in MATLAB. I'm forgetting that. So when you do this, it gives you the values, right? So it's a so I just took arbitrary some value. So it says that matrix is close to singular, or that is almost zero results we are getting. Yeah, this is another feature of MATLAB, that when you are doing some computations, in case you get a value which is being divided by 0, that is infinite. So in other programming languages, that will create an error. But MATLAB has a keyword INF for infinity. It will handle it, and it will just create, keep on calculating with that infinite value. Right? Like for example, if I say A is equal to 2, and then I say A divided by 0, right? It says the answer is INF, infinite. So it will not create an error. But normally it creates a warning that in your calculations, some infinite values, or it also has another thing. We say B 0 by 0. It will say B NaN, not a number, because 0 upon 0 is not defined in maths. So in such case also it will generate a warning. It will not terminate, or it will not generate any error. So these are two keywords of MATLAB: INF for infinity and NaN for not a number. So our last part is introduction to programming. Although we may do it a bit more tomorrow, but today we'll just introduce. So as you know, a program is essentially a set of commands. Like I have issued 3-4 commands on the command prompt. Like if I say, before that, you have seen that I have been using the CLC command to clear the command window. Similarly, you have workspace in which when you are working, you are creating number of variables. The variables are there. So in a session, you can also clear the workspace. That is all the variables, memory variables you can delete. The command is clear. If you issue a clear command, the memory variables are deleted. Now you see the window is blank. So CLC command is to clear the command window and clear is to clear the memory variables. Say I issue some commands. A is equal to some vector, I'd say. One, 2, 5. Then I say B is equal to A dash apostrophe. Apostrophe means transpose. It is the command to take the transpose of a matrix. So I say B is equal to A apostrophe. That will give us the transpose of that. So A is 1 by 5, B is 5 by 1. I can multiply them. So then I say C is equal to A multiplied B, and we'll get, of course, a single value. So I've just issued 3 commands. The first command was I created some vector. Second command was I created the transpose of that vector, and then I multiplied the 2 and we got a scalar. So if I do the same thing in a program, in an editor file, it becomes a program. So how to make a program in Matlab? Matlab has 2 types of programs. One is called script file. Second is called function file. I'm just writing it here. One is called script file and second is called function file. So I will demonstrate both because they are very, very important when we come to using Matlab actually for optimization also. So what is a script file? Here you can see it says new script, right? So it just opens a editor where we can type some commands like so we are using now a new command input with a message enter a number. The message is in single quotes. So whatever is in single quotes is a literal, and whatever the user enters that will go to the variable X. I've written 4 commands, and even if you're not aware about programming or MATLAB syntax, but just by reading them, you can come to know what we are doing. In the first command, we are giving a message, enter a number. The user enters a number which goes into the variable X. Second command, we are giving message, enter another number. The second value user enters, it goes into variable Y. Then we are adding X and Y and storing the result in Z. And then we are using a display command, disp command, to display the value of Z. So it's a program. Now we save it. So we just say save. And as I said, by default, it will save in the MATLAB directory. So I give it some name, ICT 091. So MATLAB will save it with an extension .m. So program files are usually also called M files. So it is saved with the name ICT091.m. Now we can run the program from here, or we can go to MATLAB prompt and type the name of the program and press enter. The program starts to run. It says enter a number. I say 77. It says enter another number. I say 88. It says 165. So after the program is complete, the variables X, Y, and Z, which we used in the program, they also appear in the workspace, X, Y, and Z. So we clear the workspace by the clear command. We again run the program. MATLAB is case sensitive. So if I have a program with the name capital ICT, I must type it in capital ICT. So now the workspace, as you can see, is blank. The program is running. Say enter a number. I say 5. Another number 6. So when the program ends, all the 3 variables X, Y, Z, they appear in the workspace. This is very important because this is one of the difference of script files with function files, as you will shortly see. So I just said that MATLAB is case sensitive. So if I type the clear CLC command in capital letter, it says undefined function or variable, but it also suggests that did you mean small CLC? So I said yes. Then it works. Similarly, I have saved the program as capital ICT 091. So in case I try to run it accidentally by using small letters, it says cannot find an exact match for this. The closest match is this, which is lying in this directory. So did you mean that? So if you say, if it's the same, you can press enter. It will start running that program. We will make the same program again, but in a different fashion. So it is the same program as this. So here also we were taking two values from the user, adding them and displaying them. Here also we are adding two values and we will take those two values from the user only. But what is the difference? Now this is a function file which is indicated by the keyword function. So this is the keyword of Matlab. That is why it is blue in color. Else whatever you type, that will be typed in black. Then we say R is equal to add to num pq. So add to num is the name of this function. We could give it any name. It is now our personal choice. So I have just given it name add to num. I could say add to nums, that add two numbers. So this is the name of the function, and the two values that we give to this function. The first value will go to the variable p, the second will go to the variable q, and then p and q will be added and the result will go to r. And this we are getting it back from here. Right. So let us save it, run it, and see what are the differences. The first difference will come when we are saving it. Of course, the first difference was when we were typing it actually. So remember, it always begins with the keyword function. Then the output variable is equal to name of the function, and then the input variables, or also called arguments of the function. And then the body of the function where we are doing the processing. The second difference comes when we save it. When you save it, you will notice that Matlab gives it the same name as the name of the function, add to nums. So it automatically gives it the same name. Right? So you give the same name and they save. Okay. The file may be already there, so it's just giving me a warning message. I'm saying yes. So I'm saving it with the name add to nums.m. So this is the second difference. The third difference is that how do you run it? Remember, the script file we ran by typing the name, pressing enter, and then we got some value. How we will run this? Its name is add to nums. The first thing is similar, that you just write the name of the function, but now you will give the values in brackets. Just like we wrote in the program. So 8 will go to P and 9 will go to Q after I press enter. And the result 17 will go to R, which will display here as ANS. So this function approach looks familiar to what we were doing. We were typing like G within brackets, saying the row number, the column number, like that. And so this was the third difference, how you call it. And what is the fourth difference? The fourth difference you will find if you look at the workspace window, the variables P, Q, and R, they do not appear in the workspace window. That is, in fact, the major difference. So that tells us that script files have variables which are public by default, and function files are variables which are private by default. So private means they will not show in the workspace. So if there is any question till now, you can ask. Though you will have a good feeling of it when you practice it yourself. So this is the script file and this is the function file. Then let us have one more script file and one more function file. So we are using a logical if to implement conditional statements. The first two lines are of course same. We are simply displaying the larger value. So the basic syntax is that you can see here the keywords are appearing in blue color, right? Everything else is in black, but anything in the single quotes is purple in color. So it is a literal, just a statement. So this we save it as ICT 092. Now we run, we know how to run it. So we just type its name. To display the larger number. To display the larger number. Right. The program itself is quite simple and self-explanatory, but this is the syntax. The if keyword, then the condition, then whatever you want to do if this condition is true. After that, the else keyword, and then whatever you want to do if the condition is false, and then end. So this end is for this if. Do the same thing as a function file. You can give any variable name. I'm just repeating PQ. You can give anything. In fact, whenever you are doing programming, the variable name should be self-explanatory. If you read it, you have get an idea. Okay, what is this variable about? So in a function, we take the value out by this output variable. So you can see everything else is same here. But if P is greater than Q, we are assigning the value of P to R, which is this. Otherwise, we are giving the value of Q to R. So from a function, the value comes out through the variable, output variable that we mentioned here. That is the syntax of a function. So now when I save it, it will save it by the name max2. It says max2.m. So, okay. So any two values. It is 9. It says 5. So that is an if statement in a script file to find the larger of two numbers. Same program as a function file. So main thing is that in a function file, you have the keyword function, the output variable equal to sign, the name of the function, the input variables, and then the body of the function, and the value you will take out through the output variable. So whatever value you want to take out from that function, you assign that value to the output variable. So that is about the fundamentals of programming. So also, of course, there is a looping also that we can discuss tomorrow. Howsoever simple or complex a program will be, it will use some commands, some if statements, some loop commands. That is it, right? So if there are any questions,